All right, we're working again on 12.4. We're going to talk a little bit about computing z-scores. Now, in a lot of statistics class, you don't know necessarily going to compute z-scores by hand. There's actually tables for that. Okay, but we're going to talk about simple computation of z-scores for this section. All right, and we're going to jump straight into this idea that the data value that we have, we're going to subtract the mean and we're going to divide it by our standard deviation. Okay, so values above the mean will have positive z-scores. If they're below the mean, they're going to have negative z-scores. And the z-score for the mean itself is 0. Okay, because there's no deviation from that. And if you get a 0 in the top of a fraction, it's just 0. It doesn't matter. Okay, so I'm going to look at example 5. All right, and we have a mean of 336 days and a standard deviation of 3 days. And I want to go ahead and find my z-score for 342 days. Okay, so that means I'm going to take 342, which is my data. I'm going to subtract 336, and then my standard deviation is 3, which gives me a z-score of 2. Okay. If I have 336 days and divide it by 3, that means I have 0 divided by 3, which is just 0. So that was my mean. If I have 333 days and subtract it from my mean of 336, that gives me negative 3 over 3, which is just negative 1. Okay, so simple computation. They won't always be whole numbers. Very, very often they're decimals. When you're doing them by hand, you probably won't get any real crazy decimals. But in general, we keep to 4 decimal places rounded. Okay, so if you do end up with some with decimals, do not round unless you're going past 4 decimal places. Most of the ones we're doing by hand are where you're not doing that. So you really won't have to worry about that. All right, let's go ahead and look at something called interquartiles. Okay, let's go ahead and we're looking at example 7. Okay, and I have intelligent quotients. Okay, so IQs. All right, on an intelligence test, have a mean of 100. Okay. Standard deviation, which is small s, of 16. And I want to find the IQ corresponding to these z-scores. Okay, so this time they give me a z-score. Okay, and I want to try to find the value that relates to. Okay, so what I need to do for this is I need to take my mean and add it to my z-score and multiply that by my standard deviation. Okay, so in this case, my mean is 100. I'm going to add it to my z-score. My z-score is negative. My first z-score is negative 2.25. And they tell me that my standard deviation is 16. Okay, which gives me 64. Now this number, remember we have a negative z-score. Negative z-score. Okay, which means that value we get should be smaller than the mean. So if for some reason it's not, something bad happened. All right, if I'm looking at a z-score of 1.75, I'm still going to go ahead and take my mean and use my z-score. My z-score is positive, so it's not going to change anything. and my standard deviation is 16, which is going to give me 128. And because this is positive, this means that the value should be bigger than the mean. So if for some reason it's smaller, again, it is going to be a sign error for you. Okay? And usually, going back and forth with these is not going to be too bad, just a little bit of mathematics. Okay, in this section, you're not using any z-tables or anything like that, so you don't have to worry about it. Just keep in mind that you have the formulas you got to work with here. So here, we just want to go ahead, get our data value, our mean, and divide by the standard deviation. Okay, and you can actually derive to go the other way, but we just want to take the mean, add the z-score times the standard deviation. Okay, now I want to look at this idea of percentiles. And we hear this a lot, especially when it comes to young children about their height, that they go in this percentile or this percentile of height. Okay, the first thing that we want to talk about here is we want to talk about quartiles. Okay, and we have 4 quartiles. We have our first quartile, which is our first 25% of our data. So 25% of the data will be below that first quartile point. Our second quartile, 50% of our data falls below the second quartile. For our third, 75% of the data falls below that. And for the fourth quartile, all of our data, 100% of our data falls below that set point. Okay, so when we have our normal distribution, we have our mean, 1 standard deviation away, okay, and the rest of our data is here. So if this was our median, I'm sorry, this is not median, this is our mean, this is median of our values, okay, then this would be our first quartile, this would be our second, this would be my third, okay, and obviously a fourth would be all the way out there. Okay, so the median is also going to be where our second quartile is. All right, so let's go ahead and look at example 10. Okay, and I have a baby at a 1-year-old checkup appointment. They said that the baby's height is in the 19th percentile in North America. Okay, what does this mean? Okay, so if they're in their 19th percentile, are they bigger or smaller? This baby is smaller than average for their age. Okay, and that's fine. Okay, they're smaller than the average child, but that's okay. They could go ahead and catch up. All right. The last part of this section, and I know you guys are so excited now, we're going to look at margin of error. Okay. And if we have a random sample size of n, okay, there is a 95% probability, you're not doing probabilities again, please don't freak out, that it lies in this formulation of the true population. So if we take a sample and there is this margin of error where we could say, okay, well, there's a 95% probability it lies within this margin of error on the plus side and on the minus side. Okay. So I'm going to go ahead and I'm going to do the one with the chart. So you guys have the chart. There's a total, this is example 11. Okay. I have a poll of 2,513 adults age 18 and older, and asked how many books do you typically read in a year. The results are in your chart. Okay. So we have none at 9%, 1 to 3, 23%, 4 to 6, 19%, 7 to 10, 13%, and greater than 10, 36%. Okay. Want to find the margin of error for the survey rounded to the nearest tenth of a percent. Okay, so I have plus or minus 1 over the square root of my number of survey. They told me my number is 2,513, and I multiply that by 100. Okay, so I got plus or minus 2%. Okay, and I do need the 0 for this. Okay, so it did say round to the nearest tenth. I need the 0. Don't knock it off and just say 2%. Okay. If I want to go ahead and figure that out, it's about 1.994. And that's the average number of books. I could be within sure of 1.994 books that these are accurate. Okay, how would we express this in words? Okay, we can be confident, and the wording is important here, that between 34% and 38% of adults read more than 10 books a year. Because they asked us about 10 books a year. Now remember, we have plus or minus 2%. Okay? The ones that did greater than 10 is 36%. Okay? So what we do is we subtract 2% from it and add 2% of it to get our confidence level, which is why we use the word confident. Okay? We are confident that with you taking into account our margin of error, 34 and 38% of adults read more than 10 books a year. Okay. The last thing they ask us about this part is why might some people not respond honestly? All right. And it's very possible. This is kind of a free response, but for the most part, maybe people don't want to admit that they don't read a lot. Okay, so that's a possible margin of error. Okay, that they don't want to admit it. They may think that newspaper articles on the internet equal books. That's another possibility. So there's no right or wrong answer for something like that, as long as you relate it directly to the data that you're using. Okay. There's a little bit of piece about skewedness on page 174 of your book, okay? And not all of our data is normally distributed, though that was the thing that was going on here. But when you're going ahead and looking at something, if it's skewed, that means either you've got something that looks like this, and more of your data is that way, or you got something like this, where your data is this way. Okay, so it's something you can go ahead and look at. All right, and if it's skewed to the right, okay, the tail is to the right. Okay, so this is your right skew. This is your left skewedness. Okay, so a lot of times our data is not normally distributed, but it's just nice to go ahead and look at what happens with this, though this is not a major part of this section because we really want to work with normal distribution. But as always, if you need anything, go ahead and give me a holler, and that's the end of 12.4.